Hello everyone. I come back with section 8.3, compound inequalities and piecewise defined function. So first let's talk about the compound inequality. Okay, so the compound inequalities have to have two inequalities joined by n or r. Maybe I'm gonna, you know what, and or r. Okay. Um, so there is some examples such as 2x greater than or equal to 10 and x plus 2 less than 16. Another one using r is as x less than -1 or x greater than 2. So in order to solve to solving compound inequalities contain n, here you need to follow two steps. First one is you solve for each inequalities individually, and second one is you need to have the solution set include value that satisfy both inequality from step one. So let's see an example and see what happened, right? Okay, so let's do example number one. Say determine this the many solution to compound inequality. Okay. So A. Let me write. I have x plus 1 less than 9 and 2x minus 1 greater than 8 with x equal to 5 and maybe 5. Okay, so let's do a solution for this. Let's substitute give me 1 second, let me move this one down. Let's substitute x equal to 5 into the compound inequalities, into the compound inequality. So remember that because this one have these inequalities have an and, so we call this compound inequalities. Okay. So we have so x plus 1 less than 9 now become now become 5 plus 1 less than 9. Is that true statement? You know that this is 6 less than 9 and it's true statement, right? What about the next one? And 2 times with x minus 1 greater than 8. Okay, x now change to be 5, right? So I have simplify it. I have 10 minus 1 equal to 9, which is greater than 8. Is it true statement? Yes, it is. So it's a true statement. Okay, so So in here, I can say find satisfy. Where is it? Number 5 is, maybe I will write as x equal to 5 satisfy both inequality. Okay. So this should be one solution. Okay. Now let's have another case. Substitute x equal to -5, right, into the compound inequality. We have, okay, so we have now x has become -5 plus 1 is less than 9. If I simplify it, I'm gonna have, wait, so let me change the color. See, it is -5, right? This is gonna give you a -4 less than 9, and it is true statement. Okay. What about the next one? I have 2 times with something, with x minus 1 greater than 8. Now x change to be -5, and if I simplify it, I have -10 minus 1 going to be -11 greater than 8. Is it true statement? No. It's going to say false. False statement. So so I'm going to say here x equals to -5 do not satisfy, right? Do not satisfy. Do not satisfy both inequality. So then, final step, I can say, so x equal to 5 is the solution. Is a solution, I should say, because it could be like some other solution. So I'm gonna say x equal to 5 is a solution. The compound inequality. Okay, so let me circle this. Okay. Let's have another example and see what happens. I have, but before having another example, I would like to talk about another case with solving a compound inequality with R, right? Contain R. First step, you still solve each inequality individually, as same as above. And the second step is the solution set include value that satisfy at least one of the inequalities from step 1. So in here, if you have a solution that satisfy one of them, okay, one of them, that's going to be the solution. Okay, if it satisfy both, that's going to be also a solution. Okay, so that's why I say at least one. I mean, it could be both or it could be just one. All right, So let's have an example to see what happened, right? So let's say example B, 5 minus 2x less than or equal to -4, or 5 negative 2x greater than or equal to 4. And for x equal to 2 or -3. And I will call these as inequality star. Maybe, yeah, just a star, right? So I will substitute and move to the step number 1. Right? Substitute x equal to 2. Let's check a case. X equals 2 into inequality star. Right? We have 5 minus 2 times 2 less than or equal to -4. And you know that if you simplify this, you will get 5 minus 4 is 1. And that's less than or equal to -4 is true. That is not true. It is false statement. Next one, if I have or 5 minus 2 times with 2 greater than or equal to 4, which means I have 1 greater than or equal to 4. Is that true statement? This is false. Okay. So since x equal to 2 does not satisfy they're not satisfied. Neither or how can I say, they're not satisfy both inequality. They're not satisfy at least one equality. At least one inequality. Okay, so then I can say x equal to 2 is not a solution. Okay, what about x equal to, x equal to -3, right? Let's check it. So substitute x equal to -3 into star equation. We have, so 5 minus 2 times with -3 less than or equal to -4. Just choose statement. Let's simplify it to see what happened. So I have 5 minus 2 times 3 gonna be 5 plus 6, right? -2 times -3 gonna be they're gonna be +6. So 5 plus 6 gonna be 11. less than or equal to -4. Is that true? No, it is false statement. Okay, let's move. Maybe move one more. And I say or, right? 5 minus 2 times with -3 greater than or equal to 4. And that's going to be 11 greater than equal to 4. Is that true statement? Yes, it is true statement. So because x equal to -3 is satisfies one inequality, satisfy at least one inequality. So to say that at least satisfy at least one inequality. So x equal to -3 is a solution. Okay, this is not a solution, this is a solution. Okay, that is good example. Okay, so let me talk about symbolic solution. Same, let me write better. So I'm gonna write. So symbolic solution and graphing on number line. Okay. So for inequalities, such as like some like for any two set, A and B can be say as the intersection of the intersection of A and B. Okay, so we can denote by A intersection B like this. So the notation is like an U but upside down. Okay, so we know that A intersection B. We call this is intersection notation. Okay, intersection. Okay. What else? Maybe I have like I should write this down here. Let me see. Here it is. The intersection. How about I write that up like here? Okay. I should write like this, but let me see. Okay. So I should write like this better. So the intersection of A and B denote A intersection B. Okay. And one more thing that I want to mention to use is, say, the combination, union. Okay, let's say union of A and B is A or B. In mathematics, we call A or B. Okay, this is A and B. Okay, it's A and B. In addition, gonna be A and B, but A or B actually can be denoted by A union B. Is union. All right. Okay. Let's see what else I want to tell you. Graphic. Say graphic. Okay. If I say x less than or equal to, say, 6. So here is a number line. Okay. This is negative infinity and this is positive infinity. I say middle here is 0. And I have 1, 2, 3, 4, 5, 6, 7, 8. Yes, 8. 1, 2, 3, 4, 5, 6, 6 here. Okay. And here is negative 1, negative 2, negative 3, negative 4, negative 5, so negative 5 here. Something like that. In order to get the graphing of 6, group, let me show you by the red color. I could have a bracket at 6. Okay, a bracket at 6 here, because this is bracket, because 6 is included. Okay, 6 is included. Why 6 is included? Because here x less than or equal to 6. So since you included 6, then you have to have the bracket here, right? What else? Because you are having all the value less than 6, then from the bracket here, you need to draw a line that's go to negative infinity. Okay, so it's just that. And make sure you have like an arrow here to show reader that, oh, it's keep going to the negative infinity. Okay, so that is for x less than or equal to 6. What about if I have x greater than negative 2? Okay, so let me draw a number line. And the left hand side still is negative infinity, the right hand side is positive infinity. I'm going to call this middle is 0, and then negative 1, negative 2, negative 3, negative 4, something like that. And 1, 2, 3, 4, something like that, right? So it say x greater than negative 2. So I will have to have something in -2 here, but since I don't, do I include the -2? No, because in here it's a greater than -2. Okay, so this is greater than. Okay, since it's not include, then I'm gonna have parentheses. Okay, parentheses at 2. Okay, parentheses at 2. So parentheses, because 2 is not included. Included. Right. So it will just go down or go up. What do you think? Okay, it's greater. So it should be go up to the positive infinity. And keep going like that, right? Okay, so that is x greater than -2. Okay, now I will have a compound inequality, right? A compound inequality, say x less than or equal to 6 and x greater than -2. Okay. I should, you know what? I should actually have the same scale so you can see better. Okay, you know what? I'm gonna fix a little bit here so you can have the same scale at the one above. I will actually clean this up and we'll copy down from this guy. Oops. Okay, and then put it here. You can see now that is -2, and I have parentheses and go up to positivity. Oops. All right. Okay. So now let me have another one over here. And move this one to inside over here. Okay. All right. So you can see that this is an N. Okay. A compound inequality with N. So N means that it is an intersection between A and B. Okay. So what is intersection between A and B? You can see that you will try to have the lowest value for that satisfy for both set on the top. So the lower value that satisfy for both sets should be this -2. And you should understand that why. If you try to make the use other color here. Try to make the intersection, right? So you can see that this part is intersection between two this set. So you will take from the -2 to 6. Okay, to 6 inclusive. Okay, because because this set is satisfied for both set above. Okay. So this means that from -2 to 6, that's satisfied for the compound inequality with n for this case. Okay. All right. And now, I would like to also show you what about x x greater than, sorry, x less than or equal to 6 or x greater than -2. So for this case, what happened, right? Okay. For this case, you see over here, A or B, which means union, right? Which means you just take the lowest value of the first set, which is where? Which is the negative infinity. And what is the highest value of both sets? I know that this is the positive infinity. So it should, because it's combined everything. So you see that it's combined from negative infinity to positive infinity. So you use this color, combine from here to here. See that? This and since it's an or, so that just gonna be remember that. See, or it's just gonna be union everything. Right? The first set union with the second set. You see there's just a whole line from negative infinity to positive infinity. Okay. So that for one of the for graphing some stuff. Let's have one more example for this. Let's see what happened, right? So example 2. So you guys want to solve 2x plus 4 greater than 8 and 5 minus x less than 9, right? And then graph the solution. Okay, now it's become harder, and let's see how can I handle this. This doesn't give you any value to check, right? So you had to follow 2 steps that I show you for combined inequality by n, right? So in here you need to remember that first solve each inequality individually, right? Secondly, you must find the solution set include value that satisfy both inequalities for step 1. Okay, so let's go ahead and do solve for each inequality in here, right? So step 1, solve each inequality. So I have 2x plus 4 greater than 8. Then I can, you're gonna net a minus 4 over inside, and you're gonna have 2x minus 4 greater than 4, right? You see that? Oh, you know what? How I'm gonna rewrite with all with n also 5 minus x more than 9 over here. And then I'm just gonna go ahead and do for each step in here. So minus 4 over inside. So I have 2x greater than 4, right? What about the next? What about the other inequalities? I'm gonna minus 5 both inside. Okay. So then now I have negative x less than 4. And then I will divide for the first inequality. I'm going to divide it by 2 both inside, right? So divide 2, divide 2. I'm going to have x greater than 2 for this one, okay? And what about the second one? I'm going to multiply by negative 1. Multiply by negative 1. Then I have x greater than 4. Why? Because when you multiply by negative 1, will make the direction of inequality change. Okay, so from less than now change to be greater than. Okay, that is one of the rules from the inequality if you forget it. Okay, so keep remember that. Okay, this is important one. So let me shade with some yellow things. Okay, now I would like to graph this. All right, how to graph. Okay, so I know that for x greater than 2, what happened? Right? So here's negative infinity. Here's positive infinity. Middle is 0, 1, 2, 3, 4, 5, 6, something like that. 1, 2, 4. I know that this is greater than 2, not include. So I will have parenthesis here and just go to positive infinity. Right? So that is for x greater than 2. What about let me have something else in the left side of here. Right. Okay, I have x greater than 4. Okay, x greater than 4. I'm gonna copy this down. And put it down here. Okay. So for x greater than 4, you will have to have a parenthesis at 4. We not include 4, right? And then you keep going up because it's greater than 4, right? Okay, now if you try to figure out what is intersection of these two sets, you see that this is intersection, the one over here, right? All right. So because it say x greater than 2 and x greater than 4, right? So that mean it is intersection, and I will have just gonna have another one over here. All right. And I know that it will be from 4 to the positive infinity. Okay. Oh, you know what? I have a mistake on the top here. See, I multiply by -1, right? It should be a -4 over here. Oh my goodness. Okay, so let me change a little bit here. So this should not be the solution for this. All right, so let me have a -4, -1, -2, -3, -4 over here, right? Okay. That is not a good solution. But anyway, you can see that no one can be perfectly, even me. All right. So -4, -4, not inclusive, right? And greater than that. So just going to positive infinity. And now you can see, oh, the intersection should be this guy. Better. All right. So now I can say, oh, the solution, oh, it's not really, you know what? It's not really parallel. Let me try to move. Oh, come on. All right. Think this one better. So, so then you can have from the solution should be set from 2 to positive infinity. So this is greater than -4. -4. Okay. All right. So what else? Okay, let's have another example. Have example 3. So I have solve x plus 2 less than -1 or x plus 2 greater than 1, and then graph the solution set. Okay. All right. So first step, always gonna solve for each solution, right? So I have -2 both hand side for the first equity. I have x less than -3. Or, okay, for the second equity, I also -2. And then we have x greater than -1. Okay, so let's draw it. This is a solution, but how can I do this? So I actually forgot one thing. That's For the top here, I should state the solution. I should say for the set builder notation, using set builder notation, I would write as x this set's gonna be x, that's x given that x greater than 2 gonna be the solution of this problem. Because when you combine, no, not combine, when you intersect two of these compound inequalities with an and, you know that x greater than 2 will actually uh, intersect with x greater than -4 with just the part at x greater than 2. So x greater than 2 satisfy for both of these two inequalities. Okay, so now let's move down to example 3. In order to say the solution for these two inequalities, I will write as, so your solution is using a set builder notation, in set builder notation as set of x given, it is given and it is set given that x less than 3, oops, and then or now become union, right, of the set that x given x greater than -1. Okay, so that is a way you can use the set builder notation solution. Is simple. Okay. So now let me draw the solution. Firstly, I have x less than -3. So in number line, let me move this one down. Oops. All right. I have from net infinity to positive infinity is 0, -1, -2, and -3, and -4, something like that. So here's -1, here's -2, here's -3, 1, 2, 3, 4. Look at that. And then for -3 less than -3, so I should not include the -3, right? And since I want less than that, so I should go to the negative infinity. That's why. Okay. For another equality, I have x greater than -1. So let me copy this and paste it over here. And now I should have x greater than -1. We're gonna be, maybe I use alpha better. This one, not equal -1, and go up to the positive infinity. Okay. So now you, in order to show the solution, you can say x less than -3 or x greater than -1, and then draw the combination of both these set solution. So firstly, it has to be greater than -1. This one side we combine, and the other side gonna be from -3. You go to the -50. So this is a combined solution set. Here's solution. Okay. Okay, so I have introduced some way to writing solution in the builder set builder notation. Is any other way to show the solution? Any other notation that you can have? Okay. So now I'm gonna talk about writing. Oh, wait a second. Writing solution in interval notation. Interval notation. So this is another way for you to write the notation. So something such as parenthesis a, comma, post infinity, something like that. It represents x greater than a. What else? Maybe I will have some example, okay, such as if x is less than -1 and greater than -1 and less than 3, so you can represent by the interval notation as parentheses stand for not included. Okay, so -1 will be the lowest value, comma 3 gonna be the highest value of x, and then parentheses, because this is not include the value of 3. Okay, so so that is for problem A. Let's do one more some more example. What about B? I have say -3 less than x and and then x greater less than or equal to 2. So I have parentheses because it's not include the -3, right? And I know that's -3 going to be the lowest value. So put -3 here, a comma, and then highest value of x going to be 2. So I put 2, but now I include 2, so I have the bracket. Okay, so that is things. Okay, so it's included. Okay, let's have one more. Okay, so I have -2 less than or equal to x and less than or equal to 2. So I'm gonna have, what do you think? Firstly, I know that the lowest value is -2, right? But I include it, so I have a bracket and then comma, the highest values of x can be 2, and then I bracket it because it's inclusive. Okay. What else? Okay, so yes, this is just okay that x is in the middle. What about I have CD? I have x less than -1 or x greater than 2. So what I should do now? Firstly, I know that since x less than -1, then the lowest value in here should be a number less than -1. And the number less than -1, the lowest one should be -infinity. And since it's -infinity, I just gonna have always have a parenthesis with it. Okay, always have parenthesis with the infinity. Okay, and then comma, what's the highest value for the first equity? -1, and then inclusive or exclusive. I'm gonna say not included. So parenthesis for that. Okay, now I need to have or. Or is union. So I put union. And then now I have x greater than 2. So that means 2 is the smallest number. So not include, right? And then go to positive infinity. And not included because positive infinity or infinity should be always not included. Okay. Now, yeah, I think that's all. That's all I need to show you for the interval notation. Um, um, Maybe one more. Let's see. E. I have a set of x given x less than or equal to 1, or x greater than or equal to 3. So how can I convert it to be interval notation? I know that at first it was x less than or equal to 1 over here, right? So I can rewrite as negative infinity, not inclusive, right? To 1. Now I include number 1, so I have bracket, or should be union, and then x greater than or equal to 3. So that means 3 should be the lowest value. So I put 3 and include it because it's equal here. And go to positive infinity because it's greater than that. Okay, that should be the interval notation. Okay, so now let's have a last one. F. What happened with pure set notation? X such as x greater than 0 and, okay, now I have and x less than or equal to 3. So I'm gonna change it to be interval notation as so in here you should know that for x greater than 0 and x less than or equal to 3, the intersection between this interval is actually like you draw it 0, say 0 is here, and if you draw from 0 go to positive infinity is here, and then you have 1 2 3 3 is here, and 3 you have another, you have 3 is less than that, so 3 go down to the net infinity, right? So the one that that's intersection should be this guy, the middle one, okay, and not includes the 0. So I will say this is interval notation from 0 to 3. 0 is not included, but 3 is included. Okay. Okay. Okay, now I would like to introduce about about the come on, about the solving a three-part inequality. Okay. Oops. Okay. So how to solve a three-part inequalities? I'm gonna have to work on all three parts at the same time and be sure to perform the same step on each part. Continue until the variable is isolated in the middle part. Okay, so let's see an example for three-part inequality and how to solve it, right? Okay, example 5. I have, so we say solve. Have A for less than t plus 2 and less than or equal to 8. Okay, so just gonna work on three part at the same time, right? Three part at the same time. Be sure to perform the same step on each part and continue until the variable isolate in the middle part. Okay, so that's easy. You just gonna subtract 2 for each part of inquiry, right? Because you want to separate t alone. Okay, so t in the middle, and the left part gonna be 2, the right one gonna be 6. So less than equal to 6. Okay, so let me say solve and write the solution in interval notation. Let's write that notation and graph. Okay, grab it. So for this one, if I want to change it to be interval notation, it should be rewrite as so smallest number should be 2 and not included, right? So parentheses, comma to the highest value going to be 6, but it included, so bracket. So that is a solution by using the interval notation. How to grab it? You have, say, here 0 here, 1, 2, 3, 4, 5, 6. So here is 6, here is 2, oh, 2 here. Then the solution should be 2, should be parentheses, go to 6 inclusive, so bracket. Okay. Now I'm gonna move to B. Okay. B say -5/2 less than 1 minus m over 2 less than 4. Okay, this look crazy, but actually you really try it and let's see what happens, right? So now I would like to take away this number 2. So what should I do? I should multiply by 2 for this middle term. So then you have to multiply by 2 for the left part and the right part also. So now you have the right and left one going to be -5 because this 2 cancel with this 2. And then less than 1 minus m, and less than 4 times 2 going to be 8. Okay. I can actually take away the parentheses here. Okay, now I need to minus 1 in the middle part. So I minus 1 and minus 1 for left and right. So now I will have what? -6 less than -m less than 7. So far so good. Okay, now I would like to multiply by a negative number. Okay, so I will say like multiply each part by -1. That's gonna give us a reverse inequality symbol, right? That's gonna reverse inequality symbols. So what does that mean? Okay, so you multiply it by -1 for part 1, or left part, you're gonna have 6, right? You multiply by -1 in the middle, you have m. Multiply -1 by 7, then you have -7. But now you reverse the inequality, so less than now change to be greater than, and then greater than here. Okay, so if I want to make it nicer, I would like to write as -7 less than m and less than 6 over here, because usually usually I want to write a negative number in the left hand side and the positive in the right hand side. But remember that you need to make sure the direction should be face to say for here it face to -7. So when I come back when I come less -7 in the left hand side, then the inequality gonna be the arrow gonna be face to -7, something like that. All right. Okay, so this should be the solution by inequality notation. If I want to change it to be interval notation, I will have from -7 to 6, not included because there's no equal in the inequality. And you want to grab it? Okay, so let's have a graph from infinity to positive. If t is 0, 1, 2, 3, 4, 5, 6, 7. Yeah, -7. 1, 2, 3, 4, 5, 6 is 6. Okay, so you know that the graph is from -7 to 6. So let me have not inclusive, not included, and just gonna have the set from -7 to 6. Okay. Okay, lastly, I want to introducing piecewise defined function. Okay. So definition. When a function f model data, there may not be one formula for fx that work. And that's called the function is sometimes defined on pieces of its domain. And is called a piecewise function. Piecewise function. Okay, piecewise defined function. I forgot the word define. But when it just say piecewise function, is enough for mathematics since understand. Okay. So, for example, f of x will be equal to 1 if x is less than or equal to 40 or x and x less than greater than 40 and less than or equal to 72. F of x could be equal to 2 if 72 less than or equal to x, and then x greater less than or equal to 122. Sorry, 112. X could be equal to 3 if x is greater than 106 and less than or equal to 2. Oh, actually, you know what? let me connect 112 or 112, and then 157. This should not has improved. Okay. So in here I say f f is defined in 3 pieces over interval of is domain. So in here, if I say, what is phi, if I want to find f of 100. So if you want to find f of 100, we mean in here x is equal to 100. Then what happened with the f of x? So look at x equal to 100, which is in this interval, right? Because 100 is in the middle between 72 and 112. So then you can just right away say, oh, f of x going to equal to 2. So that's answer going to be 2 here. Something like that, right? Okay. What else? Say f of 50. In this case, you can right away that know that x in here equals 50, which satisfy for the first pieces. So that's going to equal to 1. What about f equal to 120? Then you can see easily it is 120 going to be in the interval from 112 and 157. That's going to be equal to 3. Okay. And what else? Okay, so this is called like a constant piecewise function, because so constant piecewise function. Because it has the value of fx going to be a constant number. Has value of fx as a constant, as some constant number. Constant number. Okay. What else? What about, say, example 9? What about f of x equal to x minus 1 if x in between 94 and 2. 94 is included, and x and negative 2x if 2 less than or equal to x less than or equal to 4. Okay, so you can see that it is divided by 2 pieces, right? And you know what? Let me move down. Okay. So I want to say, what is domain? What is domain of F? So in order to say the domain of F, you're gonna just take a look at 2 of these interval, and you're gonna try to combine them to see what is domain of F. You're gonna say functions F is defined for negative 4x less than 2 or 2 less than 2x than 4. So domain of F is, if you combine to this, you will have from the interval from negative 4 to 4. Or if you write it as you write inequalities notation is that x less than or equal to negative 4 and greater than negative 4 and less than or equal to 4. So that's gonna be the solution for part A. Okay, either this way or either interval notation or using interval notation, or there is inequality notation. Okay. So B, I have evaluate or find f of negative 3. So f of negative 3, where what interval that's negative 3 in? The first one over here, right? See that? Negative 3 is in negative 4 and 2. So you have you want to use this one. So negative 3 minus 1. X now change to be negative 3. And now it's going to be negative 4. That's the answer. What else? If I have f of 4, what happened? You know that it is should be in the second interval now, and you will have to substitute in this form. So negative 2 times 4 is going to be what? Negative 8. Right? What about if I have f of 5? And what should I do now? And you want to check where is 5? Where is the value of 5 in the interval, in the domain that you have above? You see that 5 is not in either to this, and also it's not in the domain, right? So I'm gonna say undefined because you don't have any requirement, any x that's equal to 5. Okay. How about we're gonna try to sketch, right? Sketch graph of f. I'm gonna show you how to sketch it. What you do is at first you need to draw the xy plane first, right? This is y, this x. Okay, so you know that where is the changing value? You should know that the changing value is the common value, which is 2. Okay, so so at 2, the graph is changing, and also yeah, you have to find x equals 2 first. So here's 1, here's 2, we put 2 here. Okay, and then at 2 you may gonna draw like a dot line that's represent like a hidden line, because later on after the 2 here, the graph changing. Okay, change to the other pieces, right? Okay, so you know that at 2, where that's, so f of x equal to negative 1, x equal to negative 1, okay. X equal to x minus 1 and negative 2x. Here, negative 4, that's equal to x, and 2, that is 2, equal to x, 4. Okay, so here's 2, 3, 4. So we go up to 4, we go down to negative 4. Okay. So if you have you want to draw, you want to start from negative 4, right? So firstly, you need to have like a t table for x value when f of x gonna be equal to x minus 1. You're gonna choose some value. At first, you should choose the lowest one, which is negative 4. Right, negative 4 gonna be the lowest value. So f of x now become negative 4 minus 1 gonna be negative 5. So negative 4 and negative 5. So I will try to have negative 5 also. 1, 2, 3. 1, 2, 3. Let me go longer. 4 and 5. Negative 5 is here. So you will coordinate this, and you have the point. Negative 4 and 5 here. Okay. What else you should have? Maybe you can have one more. Let's say 0. For x equals 0, you have y gonna be negative 1. So that should also be the y-intercept. So here is 0 and negative 1. You can also find a point that actually not included, a value that actually not included is 2 in this case. So I note that it's not included. But let's see where it's gonna go, right? So put 2 into this function, and I have 2 minus negative 1 will be 1. So 2, you will have 2 and 1. but not included. So here's a 1, 2, and 1, not included. So I'm gonna have an open circle. That means it's not included. Okay, now I'm going to draw a line, go through this 3 one, and go to the 2 point and go to the point that is not included. Okay. Now I move. Now I move to the next one. Next pieces. I have another T table, and I have f of x will equal to -2x. And then I'm gonna start with 2. 2 times -2 gonna be -4. So where's 2 and -4? 2 is here and -4 gonna be here. So here is 1 point. Let me use other color for better. All right. What else? I'm gonna choose 3. See what happened? So 3 times -2 gonna be -6. So I put -6. And then I have 3 and we -6. And it's here. Okay. It actually can keep going until 4. So I'm gonna put 4 here. And what happened with that? It's gonna be -8. But remember that this is not included, right? So not included. Not included. Okay. So you have if you want to draw this, you need to go down more. Here's maybe 8 and then 4. And remember that this part is not included. So I'm gonna have an open circle. Okay, and then you're gonna draw the line, go through this 2 point and go to the open circle there. All right, so that should be the piecewise function. Please remember that each piece cannot go over the value, the changing value. Okay, so you can see the first pieces not gonna go over when x equal to 2, and also for the second pieces not gonna go over value of 2 also. So that is piecewise function graph. So I actually gonna stop this section here, and I know that this section is a little bit longer than I thought, but yeah, but this is section 8.3. If you still struggle with it, you should go to my office and get help from me. So yeah, I can make sure you're gonna understand this. Then let's see you in the next session. Okay, bye everyone.